All right, we're heading into our last panel, which is the role of verification in AI. For this panel, we have Jason Morton. He is the founder of EZKL. We have Stephen Hilton. He is the head of solutions and go-to-market at Space and Time. We have Jorge António. He is a co-founder of Atoma Network. And this panel will be moderated by Tim Khoury, and he is a partner at Lightspeed Faction. Welcome, everybody.
Thank you.
All right. Good evening, everyone. Well, yeah, the topic of this panel is the role of verification in Open AGI. We'll get into what that means, but first of all, it would be great if everyone could please introduce themselves. Maybe, Jason, could we start with you and then work?
Sure, I'm Jason Morton. I was, until very recently, a professor of mathematics. Worked on the original DARPA deep learning program in 2011, and also various crypto things since then. And a couple of years ago, I've got to combine those interests in EZKL, which is a system for verifiable AI using zero-knowledge proofs.
I'm Steve Hilton. I'm the head of solutions at Space and Time. I actually worked with the two founders. We all came from a company called Teradata. It's a big data vendor out in space. Got tired of playing around with Web 2 and decided to bring that paradigm to Web 3.
Yeah, and I'm Jorge António, CTO and co-founder of Atoma Network, decentralized network for verifiable AI inference. I have a PhD in mathematics. I worked as a machine learning engineer in the past, and I've been involved in the Web3 space since 2020, where I've worked as a engineer and researcher in topics such as consensus, applied cryptography, and ZK. Yeah.
Cool, thank you guys. Well, we're going to try and ELI5 this, so I want to break this down into question words. So I think the first place to start is, what is verification? What does that mean to each of you? Feel free, whoever wants to jump in to do so.
I guess, I don't know, we all want to go at once, or no? Verification, I'll answer it from the non-mathematical perspective here. I'll let you guys, you seem like you got the math covered. Verification is really about trust, right? It's verifying that the work done is as appropriate. Not to say that it's done right, it's just done as expected. At Space and Time, we have a piece of cryptography, a ZK snark called Proof of SQL. That's the marketing name, Proof of SQL. It's a way that we can produce a proof that a query run on our platform, the query itself and the data that it ran on has not been tampered with, and then we produce that proof and hand it off to a verifier. It's that verifier that their job is to check that what we did is in alignment with the expectation of our user, right? We have our own verifier network, but usually you want the proof and the verifier obviously to be different. So I'll just, like, from a very high level perspective, it's really about trust, and not just trust, but being able to say, everything was as expected from the user.
Yeah, I totally agree with that, and I can give you the perspective on how we see a verification at Atoma, and it's really about, like, whenever you are requesting, say, AI compute from some machine that you have no control through some API or through some decentralized network, how can you have a guarantee that the model that we requested to run the inference actually did the computation, right? So, for example, I don't think we can, for example, know that if I ask a question to GPT-4 and I'm paying for the API fees they provide for GPT-4, we don't have, we expect that the answer is actually produced by running GPT-4 on my input prompt, but it could be that OpenAI, in order to optimize their costs, their fees, they can actually route it through some less capable model that can give some reasonable answer. But in some cases, it might not be as good as I would expect by running just GPT-4. And this phenomenon is more important when we enter in the world of decentralized networks, because now nodes, they are not necessarily entitled to some company reputation, some national regulations and whatnot, right? So these nodes, they can do basically whatever they want to kind of optimize their costs, and they can be claiming that they run a very powerful model, like 70 billion model parameter, but at the end of the day, they are running just a 7 billion model parameter. They are not producing such a like a consistent and good answer.
Okay, awesome, thank you. What about
Yeah, sure. It's more or less the same story. I like to think about digital signatures. I think of zero-knowledge proofs as generalizations of digital signatures. There's a setup phase, like creating a public-private key pair. Similarly, we create a proving key and a verifying key, and then anyone can prove, I used this model or a model that has this commitment on an input that has this commitment, got an output that has this commitment, and the verifier can believe it with the same kind of certainty they would believe that someone signed a transaction using ECDSA. Of course, there's a social element to that, which is kind of what is the right verifier, right? So we make verifiers you can deploy on Ethereum. It gives you a nice kind of way of thinking about what is the right contract. But that notion of what is the right contract or what is the right verifier is really a social consensus problem. And so that's something that the math sort of can't directly solve for you, and your system has to think about.
Well, that's the thing I want to ask about, actually, because I can run a query through GPT-4, and GPT-4 can be confidently wrong. But I could have a proof, a ZK proof. So what does a ZK proof really mean in that context?
Yeah, I mean, it means that the model that you promised is the model that ran. It doesn't mean the model is right, but it's proof of execution. And
I'll absolutely. We're working with a couple large enterprises. If you're curious, I don't know if I want to say it up here, but I'm happy to share offline. To do verifiable LLMs, which is really like, there's the compute side of it, but that use case is more about feeding the correct verified data into the LLM for training, right? So as a use case, imagine like we're in Europe here, imagine you have a large organization, you have a corpus of legal documents that you want to put into an AI and ask it, is this GDPR compliant? Or what is my GDPR exposure, right? To do that, you don't want your LLM trained on Reddit, right? Like it's going to hallucinate. And so in that particular use case, you want to have a data set which is only GDPR and that you can verify as only GDPR, right? Because then you can't, it's not going to prove that the answer is absolutely correct. That would be on the processing side, right? But on at least you can say, we can verify that it's not going to hallucinate anything from Reddit because somebody went off on a rant, and now that's what you're basing your legal, AI on.
Yeah, and I think that's actually a very good point, because it's important that we make a distinction between what we call verifiability and model integrity, right, in this case. So model integrity is actually have some sort of assurance that given a prompt, the model, if it's run correctly, will provide you with an answer that actually makes sense for your use case, for your situation, right? And this is definitely a great example, but in general, this is a very difficult problem. Usually typically for these large language models, you don't have control, or you cannot kind of attest all the training data that was fed into the model. So for example, Llama 3 has been trained on 15 trillion tokens on the internet, right? And I think this is there are some rough estimates that this is around half of the content on the web in a way. So it's kind of unfeasible to attest for all the data in which case. And so I think this is a very difficult question for this general purpose large language models, but when you kind of you kind of reduce the context in which you want your LLM to operate, in for example the case you specified, then actually it makes a lot of sense, because now you can have control of the data that you fed into the LLM. Yeah.
Cool, makes a lot of sense. So I guess we've got, to summarize, verification of data, verification of execution, and then this concept of model integrity, which is slightly different but related. Okay. Next question I want to get into is, why is verification important? Is it always important? Is it more important for some things than for others?
Yeah, maybe I could start with that. So this is an incredibly difficult question. I think I like to go back to, if you look at these accounting ads from 100 years ago, when you're trying to convince people to go from paper to adding machine or adding machine to computer, it's very similar, right? They're like, oh, we have this accounting department. It's fine. I trust them. They're really good. And then you're trying to convince them that they should switch to a computer, and the language they used to make that sale was very similar. They talked about proof a lot, right? Like, you need not something which is just fast or accurate, but you have to have proof that it was true, and they felt that the computers at those times, just by using a computer, provided that proof. Of course, we can provide now a much higher level of proof. I like to think about it as something like a cryptographic audit that has 100% coverage and perfect confidentiality. Something that no accounting firm could ever provide. And that's a pretty powerful concept. However, it's expensive. Today, it won't be expensive in 5 years because the rate is increasing very quickly. The speed of these things is increasing 1 to 3% a day. But that proof works best in adversarial environments. So you're worried about fraud. Blockchain obviously is super adversarial because you're letting someone untrusted run a computer or run a computation for you, and they're going to try to steal your money. I think in cybersecurity, it's also an adversarial environment. I think in situations where you have a contract with the provider and you have human oversight, it's less appealing.
Just quickly on that, and then I'll give others a chance to jump in. You talked about cost. What is that cost differential today? And presumably there always will be a cost differential, but it gets smaller over time.
I don't think there'll always be a significant cost differential. If you look at GPUs, you get double every sort of 2.5 years. And we're looking at, like I said, around 3% a day improvements in ZK. That's going to catch GPUs pretty fast. I think long run, we're looking at maybe 30% overhead. It's going to be like ECC RAM. Just runs in the background. It's a little slower than unchecked RAM, but mostly you don't need to worry about it.
Okay, so it's not thousands of times more expensive.
On the long run.
And I was going to say, I mean, that's a great point. It's really securing the value, right? The guaranteeing the value. And so really, if your cost of securing it's more than the value, then it doesn't make any sense. And so it's going to be a sliding scale, right? And like you said, it's going to get cheaper over time. Which means that it will be more pervasive over time, the use of verification. And then there's going to be a whole class of use cases. It just doesn't make a lot of sense. If you're making a video game, right, you may even be moving in-game currency, which may even be tokenized on-chain, but does it really matter that much? I mean, eventually, maybe it becomes so ubiquitous that, hey, why not? But I think that's a long time out.
Yeah, so I actually have to disagree here. I think we need verifiability whenever we don't want to trust on some centralized API. So for example, we have seen a lot of discussions around decentralized physical infrastructure, DeepIn, that we want to use for a bunch of use cases, including AI. And so if we want to rely, instead of wanting to make a call to OpenAI API, I actually want to use some decentralized network because it might provide cheaper costs and whatnot. I would argue that in that case, you always need some sort of some verifiability guarantee. That said, there are plenty of applications in which we can use decentralized AI and verifiable AI, and I will argue as well that certain applications require very high trust guarantees, very high verifiability. Others, they require mild assumptions. So for example, if a DeFi protocol wants to have access to some AI functionality, to take into account fund management, whatever answer the smart contract gets, it should have a very high trust guarantee, right? And that will require high verifiability. You need to run this through either a ZK proof or a trusted execution environment attestation, or some consensus protocol like what we do at Atoma. And in all these cases, you might have to pay a higher amount to have access to this verifiability, to these trust guarantees, right? On the other hand, so for example, if I'm playing with on a game and whatnot, or just interacting with some chat application, I don't need those very high verifiability guarantees. But I would argue that you still need to have some sort of like guarantee that you are paying for what you get, right? So it might be the case that like the AI provider is not using the model that you requested to, and even though you might be happy with the answer, you could have been paying less to get like the type of output you are getting, right? And so I would say verifiability in that sense is also required in a way to kind of entrust that all like the nodes in the network, they actually are running the type of AI compute that you requested to. Otherwise, you could just basically, you are paying an extra amount that you will not have to. And so also just to finalize here, on the cost side, for example, on Atoma, we have developed like this consensus, sampling consensus, in which in a lot of cases where you don't need these high amounts of verifiability, we can just run inference with a single node in many cases, and from time to time with some given probability, we select some more nodes to attest for the result. It actually can prove that you have some Nash equilibrium, and the advantage of this is that you can run, say, 90%, 95% of the requests with a single node at native cost while still having verifiability.
Awesome, thanks, George. And I was just going to say, yeah, disagreement is good. In general, the spicier the take, the better. But yeah, that gets us into, I think, sort of the different approaches that are there. You've got zero-knowledge proofs, crypto-economic sort of mechanisms, trusted execution environments, and maybe sort of newer techniques that we're less familiar with. How do you think about the trade-offs as it pertains to what each of you are building at your respective companies?
I'll just say, Spacetime, we've kind of thrown in for the zero knowledge, right? Like our network does have crypto economic as well, but that protects you up until the point where it's no longer cost effective to not cheat, right? As soon as it becomes cost effective to cheat, then. And so there's a lot of variability. You have to get that exactly right, whereas zero knowledge is just math, right? It either equates or it doesn't. And so that covers all of the use cases there. Trusted execution that more obfuscates than verifies, right? Like I think that in conjunction with ZK is a good approach, but it doesn't actually prove anything. It just obfuscates. You can't see what it's doing, which has a lot of good value in it of itself.
Yeah, so it really depends on the type of application you care about. So I agree that ZK is ideal for any application that requires high trust assumptions because you are only relying on the math and on the developer implementation that might have bugs, but I mean, that's part of the game. I would say that trusted execution environments, they also provide you attestations that can confirm that a given computation run correctly. It's just like you need to trust the vendor, right? But the advantage is that you can actually run the computation without having to do, without having the overhead costs of like ZK or do this like crypto economics strategy and whatnot. Yeah.
Two examples that I like to bring up that I think illustrate the situation is, first of all, rollups, right? We have ZK rollups, we have optimistic rollups. There is, in fact, Oasis, there is a completely enclave-based rollup. But if you ask most people in crypto if they would trust their money to someone running an enclave on their computer, almost everyone says no, unless they're invested in that, right? And I think that indicates that we just don't trust enclaves for things that are critical or truly adversarial environments. The other example I like to bring up is the drone, right? So imagine you have a drone. It's deciding whether it's to drop a bomb on a building. It can take a picture of the building, hash it, send it to the server. Server makes the decision, sends back the result. If that's accompanied by a proof, then the drone can check if the model that ran was authorized or not. If you apply the sort of crypto-economic or optimistic approach to that situation, you're forced with a dilemma of trying to roll back the fact that the building is destroyed, which is just not possible, right? Or certainly not without if anyone's lives were lost. So I think these things all have a role to play. I think they have different trust assumptions, different security assumptions. Obviously, I like ZK because I think that's kind of the farthest over in terms of how much trust you get. But you do pay for that. Yeah.
Yeah, I think that's actually a super interesting example, the example of the drone. And I think that's not, it's actually a very good example. So I'm super excited about like real world asset tokenization. And I think this is possible through using smart devices. So for example, you can have like some smart glasses or some smartphone whatsoever that can actually use some AI model to check, okay, I own this, I don't know, like this item in the real world, right? And it can use ZK to actually prove that this computer vision model, object recognition, actually run correctly. And then this can be minted directly onto the blockchain. And I think this could be a very interesting vehicle to kind of bridge the real world asset tokenization with blockchains in general. So I think that's definitely an example where ZK really shines there, yeah.
Makes a ton of sense. So there's a spectrum of solutions. Some combination probably makes sense over time as certain approaches become cheaper. Probably makes sense to use more of that. Cool. Well, another area I want to get into is the applicability of verification in Web 2 as it pertains to AI. I guess there's two questions here. I guess the first is, why should Web 2 AI companies care about this? And the second, which we can get into afterwards, is, does this help with some of the regulation that we're sort of starting to see in the space? So any thoughts on, I mean, really, either of those two questions would be great, please.
I mean, on the regulation front, we're in a difficult place because I think we see that ZK can solve a lot of regulatory problems in a privacy-preserving way, but their legislative side is not there yet, right? So we have to do the hard work of convincing governments and legislatures that that actually makes sense and that's good enough, and they should trust that, where the laws are all tailored to, you must find out who this person is, not you must prove that that person doesn't have, sanctioned or characteristics. So.
Yeah, I'll mention that we do have, I think ZK proofs are largely the realm of Web3 today, but not entirely. So for example, we have audit firms, right? And so Spacetime has this idea of a tamper-proof table that you can run ZK proofs on. Tamper-proof, we call it immutable. It really means it's append only because we have to collect the commitments as we ingest data, which is a great use case for Web3, but people sometimes are like, well, we have actually quite a few enterprise customers. Why is that? Well, because, like I said, an audit firm has this great tool now where as they're performing their audit, they have a place of record that they cannot change. So if they get to the end of the audit and they don't like the results, like, well, sorry, that's what they are. You cannot undo that. It's an example of something that doesn't belong on chain, because no enterprise company today is going to say, yeah, take all my financial books and put it on chain, right? But the ZK proof actually helps the audit firm, because they can go back, instead of doing a secondary audit on their audit that they have to go prove their work to their customer, they can just hand them that proof and say, look, we built this as we went, and you can mathematically prove that we've not tampered with it.
I guess, sorry, just really quickly, in that example, do you need the blockchain, or can you just, say you're running whatever, you're deciding who gets a loan, right? And you've got a bunch of financial data about, an applicant, and there's an AI model that decides it's a binary outcome, yes or no, maybe another outcome, how much. Do you need to store any of that on the blockchain, or can you just run the ZK proof alongside that computation?
I'll say that we do store some of the information on blockchain. It's not the data itself, it's the commitments I mentioned. So as we're ingesting that data, we're generating these commitments. And so there's no way, obviously, to take that back to the data, so it's secure, but it's a way that we can publicly show our work and say, like, we as the vendor, as we're ingesting this, we're putting that out. You can always go and tie everything back, right? So yeah, we still use blockchain. I think that's a great, that's a use case for blockchain, even in a Web 2 company, even though they may have no idea, or again, that's more our role as a Web 3 company. But they can use that in their Web 2 environment to always go back and check our work.
So it's about the audit trail, is what you're saying?
I'm sorry?
It's about the audit trail. Is that right?
Yes. It's about an audit trail.
Okay, understood.
Yeah, so I really think Web2 companies will have more interest in decentralized AI overall, because I think given the current constraints on GPU markets, GPU access, compute access in general for AI pipelines, with all the overburden costs that transpires to developers and companies, I think Web3 is well positioned to kind of put forth incentives to align compute networks to kind of handle a bunch of these services at lower costs. And if that's the case, then any Web2 service will need to actually trust that whatever is running on a given decentralized network is running as they plan to, right? So it will be catastrophic for a Web2 company to actually provide some service relying on some decentralized party in the back end, and this decentralized party is behaving maliciously, right? This will basically have huge implications for the reputation of this Web2 company. So I think it will, from a perspective of optimizing costs, that Web2 services will be more interested in decentralized networks for compute, namely in AI, and therefore verification will be important in that case. Blockchains will still also have definitely a role to play, and just leveraging on your example, for example, at Atoma, we are also using blockchains not to provide to process requests, AI requests, but you use it to store commitments to the input data, right? So we don't store all the input data that has the prompt. It might have the output additional data that's too big, but we can actually commit that to the blockchains, and the blockchains in the future, I can foresee that there will be kind of this universal registry where you can have commitments for all sorts of requests that can come from Web 2 or Web 3 protocols. Yeah.
Awesome. Well, we are approaching the end of the panel, but I did want to ask each of you, for people in the audience who are interested to learn more, what are the best resources that you guys use to stay up to date with this space? And maybe you can also tell folks where to find your companies on social platforms or elsewhere.
Yeah, so I'll start on this one. So regarding Atoma, you can find more at Atoma _network on Twitter. We also have a website, atoma.network. On the GitHub, we are going to release our white paper tomorrow, so there will be a lot of content over there, and a lot of content around crypto and AI. I learned, in my path, I learned a lot from reading papers, and I leveraged basically my academic background. But I think there is great readings or on the web around AI, the capacities on this LLM news, everything that is going on the internet. There is an amazing Twitter account called epoch.ai that has a lot of data regarding compute requirements, growth of AI models, etc. So I really recommend to look into that Twitter account, epoch.ai. And then I think over in the coming months, and so once the space gains more attention and more traction, we'll see more blog posts and more accessible material. But I think the best way is to look out for great projects like Space and Time and EZKL in the space. Yeah.
For Space and Time, I would say reach out to us, spaceandtime.io. That's our webpage. Has all links to all the socials. Usually the socials are Space and Time DB. My name is Stephen Hilton. You can reach out to me directly. We have open sourced our verifier. We've open sourced our GPU acceleration framework for proofs. I would say if you really want to get involved, go read the documentation, dig into these open source projects, ours and others. If you've never run a node, because sometimes running a node for for a blockchain is a substantial amount of work, can be. Go run a verifier. Verifiers are usually pretty easy to run, and they're pretty lightweight. Like, not the prover, but the verifier. And so like, the more decentralized those verification networks are, the better life is for everybody. So that would be what I'd say.
Awesome. And we're at EZKL.xyz at GitHub, zconduit/Ezekiel. Best place to start there is with the notebooks. So we have Jupyter notebooks, Python notebooks. You can do everything there using Google Colab in your browser. Don't even have to install anything. That's the way most people get started with it. For more general ZK, I recommend getting a PhD, which is a lot of fun. And if you don't have time for that, there's some articles that you can get up to speed in a few days.
Awesome. Well, that's all we have time for. Please give a round of applause to our 3 panelists. Thank you very much.
Thank you.
Thank you.